Shout out to Liz. There's a baseball. There's a baseball thrown straight up in the air at a maximum. You guys focus. At a maximum height of 17 meters. All right. So what's the first step? Draw a picture. Right. So there's a baseball player. Her name is Liz. Well, you guys were pretty harsh on the last. You guys made fun of Ruth because she was too short, and now you're making fun of Liz. Those I didn't finish her arms, guys. There's her arms. I didn't move on yet. So, anyways, sorry, Liz. Haters are gonna hate. You know what I'm saying? So, Liz is throwing a baseball straight up in the air. Now, Liz is tall because it says that this thing goes 17 meters in the air. So we'll make this 17 meters. Okay. And how long does it take her to do that? Well, by the way, let's not get ahead of ourselves. All right, so Liz throws the ball. Liz is sad because everybody keeps making fun of her because she's tall. Whoops.
One eye.
It's a side profile. And so this is, let's label some things. This is our initial position. What do you want to call it? We'll call it Y0. Y0, the initial position is 0 meters. Up here at the top, we're going to call this Y. Oh, shoot. I don't know. This thing is not always cooperating. All right, so it says, what is the acceleration experienced by the ball when it reaches its maximum height if up is the positive direction? So going up is positive and going down is negative. So what's the acceleration? Guys, you know this one. The acceleration is G 9.8 meters per second squared. But we should probably point out that the acceleration is in the negative direction, right? So that's really your answer.
That's it.
Are we done already?
No word showing.
If it's going up, if it's going up, why is it negative?
It's slowing down.
What, how do we know?
Because the acceleration due to gravity is going down.
Don't make sense at
Oh,
all.
that kind of does make sense. But it does to the maximum.
Well, what you're doing, you got to think of it like this. There are forces, and I haven't taught you forces yet, right? So there is no acceleration or no force on that ball continuing to force it to go up. Nothing. Nada. Zero. Zilch. But there's a force being applied to the ball from gravity that's slowly bringing it down towards the center of the earth.
So
it's like a rubber band, right? So if I have a ball connected to a rubber band and I throw that ball up, what's going to happen? Eventually it'll stretch the rubber band, but what is the rubber band doing? It's pulling down the whole time. So the ball can still continue to go up, but it's still pulling it down. So the acceleration in a roundabout way is pulling the ball or slowing the ball down until it comes to a stop up here at the top at the maximum height of 17 meters. And it's accelerating it in the opposite direction. Remember we did this before. It's like a car hitting the brakes, right? Here's a better example. Maybe this will make more sense. So here's a fancy car.
Okay.
It's a Cybertruck. And it's whizzing along at 2 meters per second, right?
Yeah.
And then I ask you guys, I say, hey, do you think we could slow down a Cybertruck if it's only going 2 meters per second? By the way, that's really fast. And you guys say, yeah, we could do it, Mr. Adams. How do we do it? And I said, well, we're going to tie a bunch of ropes. Okay? We're going to tie a bunch of ropes, and we're going to put a bunch of us, and we're going to be holding the ropes. But we're going to go this way. So each one of us is holding the rope, and we're going to pull this way, and we're all going to pull this way, right? Every one of us, this whole class of us, we're going to pull in the opposite direction. And I don't have time to draw all of you guys in this picture, but if enough of us pull this way, what happens to that Cybertruck?
It slows down.
It slows down, and then it'll stop. And if we continue to pull in the opposite direction, so our acceleration is going in the negative direction. It's going this way. It's negative. If we label going to the left as negative and going to the right as positive. And the velocity of this thing right now is 2 meters per second in the positive direction. But at some point, my little Cybertruck will have a velocity, well, we'll call that V1. We'll have a velocity of 0, right? Because it stopped. We're still pulling on it. So the acceleration is going in the negative direction, but the velocity is stopped. And then eventually what's going to happen with the Cybertruck? It's going to go back this way. Same thing with the ball, except we're rotating it on the y-axis. The ball is going up. Gravity is accelerating it in the opposite direction. You're thinking of like positive and negative numbers, which is sort of true, but really I've just got acceleration going in the negative direction while the velocity is going positive. They can have different... Does that make sense?
Yeah.
Yeah.
Because the positive and the negative really represents the direction. So they can go in opposite directions for sure. That's a good question. All right.